Alright, let's talk about the respiratory system. Let's go over it one more time. You know that we have to motion between oxygen and carbon dioxide. We know that oxygen is needed and carbon dioxide needs to be left behind to get rid of. We talked about several systems that are involved in moving these two gases. Of course, we're going to touch on the respiratory system. Organs that are involved with the respiratory system are going to be the nose, pharynx, larynx, trachea, bronchi, and of course the lungs as a whole. Cardiovascular system and respiratory system, they have to work together. They have to be efficient together. The pulmonary arteries are going to carry the deoxygenated blood to the lungs and release the carbon dioxide and gain the oxygen. Okay. The pulmonary veins are going to, of course, do the opposite. They're going to carry the oxygenated blood from the lungs to the heart, where it's pumped through the body. We talked about the organs. Gas exchange only occurs in one spot, and that's the alveoli. The other respiratory structures are merely conducting the passageways to allow air to move to that area. They also are in charge of purifying, humidifying, and warming incoming air, so they're ideal for this gas exchange to occur. Functions of the respiratory system obviously are gas exchange. It also is necessary to regulate pH, where carbon dioxide is converted to carbonic acid. We'll talk about it in a bit. We have receptors for the sense of smell. We have filters for inspired air. And we produce sound for vocalization. In respiratory organs, there's going to be two areas. The conducting zone, that's the respiratory passageway that brings air prepared for gas exchange, and the respiratory zone, that's the actual site of gas exchange at the alveoli. You know how doctors are, cutting things in half, so we got an upper and a lower respiratory system. The upper is going to include your nasal cavity, pharynx and larynx, and then your lower is going to be your trachea, your primary bronchi, into your lungs. It's the way they divide it out to distinguish where there's obviously something wrong. The nose is the first portion of the respiratory system that we'll talk about. It's the only external visible portion of the respiratory system. The two holes are the nares. The interior of the nose is its cavity, which is subdivided into two areas by the septum. You have your olfactory receptors, which give you the sense of smell. Okay? But this is done by neurons. They detect odor molecules, and then a signal cascade leads to the brain, and you can tell you it's, a flower. It's not memorized. You have to learn what something is. You don't just smell coffee and know it smells like coffee. You have to learn that it smells like coffee. It's not a natural, innate situation. Okay. The rest of the mucosal lining, of course, is going to be rich with thin venules. This thin venules is any air that's entering your nose is going to pass over these thin veins, and that'll allow it to be warmed, because the air could be cold, 20 degrees outside, lately. You inhale it in, it's going to warm the air, and it's no longer 20 degrees. It'll warm to body temperature. Because of this, those veins being so superficial, you're more apt to have bloody noses. That's why people get a lot of bloody noses. You have lots of mucus. We know that mucus is favorable for catching debris or bacteria, anything that's non-self in it, and allow it to be destroyed. We have lots of cilia, which is the hair in our nose. That allows for motion towards the throat. Whatever you can't get rid of in the other fashion, the cilia will push it down your throat, and you can swallow it, and your stomach will take care of it. structures have a purpose. Obviously, in the nasal cavity, the larger the surface area, the more debris or unwanted things can be caught. So larger surface area is real important. The nasal and oral cavities are separated by the palate. We talked about cleft palate and what that was. We talked about paranasal cavities, that the front sphenoid, ethmoid, and maxillary bones, they help lighten the skull and offer resonance chamber, and they also contain mucus which drains into the nasal cavity. So they provide a lot of important things. Blowing your nose will actually help provide some relief in how painful those cavities can be if they're overfilled. We talked about sinusitis and what that is, the inflammation of the sinuses. Make sure you know any disorders. Pharynx, muscular passageway. Its common name is the throat. It is a passageway for both food and air. Air enters the nasopharynx from the nasal cavity, descends through the oropharynx to the laryngenopharynx to the larynx. Okay. Food enters through the mouth, travels with air through oropharynx, laryngopharynx. But instead of entering the larynx, food goes to the esophagus, which is posterior to larynx, which is protected by the epiglottis. The epiglottis is very important. That's what protects you from that. It went down the wrong tube, or if you're choking and all. So it's really important. The pharyngeal tympanic tubes, very important tubes. There's 2 of them. They drain from each ear into the nasal pharynx. Okay. It helps relieve some of the pressure, and this is the area that they do tube if there is a problem. When you have a cold or an illness, that's why they look at your mouth, your nose, and they look at your ears. It's because of this. Many infections to the middle ear comes therefore to the throat. Okay, so it moves. The larynx, also called the voice box, okay, plays a large part in speech. It directs air and food into proper channels. It's made of hyaline cartilage. It has the flap that looks like a spoon, that's the epiglottis. The largest hyaline cartilage is called the Adam's apple. Who has an Adam's apple? Men or women? Both. Good. Okay. Vocal cords. Let's see. Okay. Let's see. They vibrate with expelled air. So if you're expelling air, they're going to vibrate. That produces a vibration, a sound. That vibration gives us speech. The slit, the space between them, is called the glottis. Okay. Trachea, also called the windpipe, travels from the larynx down to about the 5th vertebra. It's C-shaped. Its rings of hyaline cartilage. Remember, it's facing this way. So the closed portion is outward, is what you see in the neck. Okay, the part that's open is in the back. Here's why. Behind it is what? Esophagus, where the food goes. So what if you eat a piece of steak? If this C-shaped is fully closed and something hits it, it's not going to go through that easily. If you have this C-shape, it allows for me to chew larger pieces of food and not disrupt the trachea at all or cause damage. That's why there's that great C-shaped in the trachea. Okay? Heimlich maneuver, make sure you know the steps to the Heimlich maneuver. Your victim demonstrates choking. The universal sign is this. Obviously their eyes are wide, they're kind of panicking if you're catching them right at top. They can't talk, which definitely demonstrates there's something wrong in their throat. You have to tell the victim you're going to help. It's going to be okay. I'm going to help you. Get a standing position. Make sure somebody's dialing 911 while you're going to do all this. Okay? Standing position. Okay? Perform back blows. you know, heel of the hand to the shoulder blade, okay, with some force. You are trying to help somebody breathe. I'd want somebody to nail me if they knew what they were doing, hit me hard, okay? If that doesn't work, stand behind them, legs separated. That's to catch them in case they pass out, okay? Thumb just above the navel, hand wrapped around it, and then the other hand on top of it. And then you're going to do the maneuver, which is in and up, 6 times at a time. You are going to be so adrenaline pumped that you're doing this. Should be picking up this person off the ground. You've got that much strength at this point. That's okay. You want to do it because you want to expel that whatever's stuck in there, okay? And make sure you understand that. It's important, okay? Main bronchi, remember that's where it initially breaks off from the trachea when it's entering into the lungs. The lungs itself, it occupies most thoracic cavity. It's within the mediastinum where the heart is. Each lung's divided into lobes, 3 on the right, 2 on the left. We talked about why in lab. I know I got you on that one. Not why. Because of the heart. Okay. Lungs protection, covered with visceral pleural. That means it's touching the lungs. Visceral means to touch. So visceral pleural is protecting the lungs. It's touching the lungs. It goes around the lungs. Then you have the parietal pleural, which is not touching the lungs, but it's another layer that's surrounding it. Okay? It's going to be producing a fluid, so there's some lubrication. So obviously they don't have any friction. Okay? Respiratory tree, we saw that in lab. We went from primary, secondary, tertiary, all the way down to bronchioles, terminal bronchus, and then alveoli. Okay, that's a tree because it's branching all the way out. Okay, and they're getting smaller and smaller and have different jobs. Okay, respiratory zone. Okay, that's where the alveoli are because remember that's where the only gas exchange can occur. All right. Thin walls, alveoli, squamous epithelial cells. It's thinner than a sheet of paper. There's pores connecting, offering more spaces. It really does look like a sponge. Okay, and that's because gas has to be exchanged there. Okay, air-blood barrier. Okay, the respiratory membrane, where gases go. Exchange of gases is by simple diffusion from high concentration to low concentration. Okay. Oxygen from the alveoli to the blood, and carbon dioxide from blood to alveoli. Defense mechanisms for the respiratory system, like everything else you need it. You have macrophages, even in this area of the lungs, to make sure that nothing is getting into, so they help destroy them. Cuboidal cells cover alveolar spaces. They're going to produce surfactant even in here for a lubrication mechanism. There is 4 functions of the respiratory system required for respiration to occur: pulmonary ventilation, external respiration, respiratory gas transport, and internal respiration. If you're missing any of the above, you can't have respiration. Breathing is completely mechanical, and it's all done only by changes in pressure. You're not inhaling or exhaling. It's pressure only that causes you to breathe. Okay? So, as size gets smaller, pressure is going to increase. Okay? Inspiration means into the lungs. Diaphragm and intercostals are going to contract. Volume increases, so pressure decreases. If volume goes up, pressure does the opposite, decreases. So intrapulmonary pressure decreases Atmospheric pressure stays the same, okay, and it causes air to come in. Expiration's the opposite. It's out of the lungs. It's a passive process, no work required. Muscles and diaphragm are going to relax. Intrapulmonary pressure, or intrapulmonary volume, is going to decrease. Therefore, pressure is going to increase, so you expel until it's equal. Okay? Intrapleural pressure needs to be kept equal to atmospheric pressure within the lungs. If it collapses, that's where you have a pneumothorax, which we talked about. Okay. Factors that affect respiratory capacity, obviously sex, your age, position, activity levels, general health, all that good stuff that affects all of us. There's a refresher for you, what tidal volume is and stuff. You do this in lab. Make sure you know what that tidal volume. You'll do it in lab Friday. Okay. I think non-respiratory ways to move air. You can move air by coughing, by laughing, sneezing, crying. All that's going to clear debris out some way or another. Okay. All right, we listen to sounds, bronchial sounds, vestibular sounds. They're very distinct and different. Cracking and wheezing, we talked about how when you listen to them, why they're so different on somebody and how a doctor can distinguish between the two and what's wrong. We talked about external respiration, that's lungs, oxygen to blood, carbon dioxide from tissues. Internal respiration is exchanging blood and tissue cells. And then the law of diffusion is gas moves from higher concentration to lower concentration. Pressure. External respiration, we talked about the pulmonary circuit to systemic circuit. How you need oxygen go to lungs, get oxygen from alveoli, back to the heart, distributed through the systemic. Carbon dioxide, same thing. Gas transported in blood, oxygen transported two ways. It's going to attach to the hemoglobin and red blood cells, and a small amount is carried within the plasma in a dissolved fashion. Carbon dioxide transported in two ways. It's transported as a buffer in the plasma, and it's also transmitted on another side of that hemoglobin. We talked about carbon monoxide poisoning. We talked about internal respiration. Okay. Make sure you look at it. Control of respiration. Okay. Tide-like breathing, normal breathing. It's set by neural regulations. It's your mind. Okay. It's basic rhythm. Diaphragm and intercostal muscles controlled by nerve impulses coming from the medulla. Okay. We have physical, so things that are non-neural also control our respiration, exercise, talking, body temperature, okay, emotional factors. You're all depressed because you don't see me every day. I don't know. Okay, chemical factors, carbon dioxide, oxygen, hydrogen in the water. So also check, again, emphysema, lung cancer. Those are another two diseases or disorders that you're required to know about. Okay, please run through this like I said. Again, if you're studying and you're having problems, study like I've been teaching you, okay, and you'll do fine. All right, good luck.